Myself, I am Dr. Jntuh. In this class, I am going to discuss with the operating system structure. Before moving to the topic, these are all the contents which we are going to discuss now. Operating system structure, operating system debugging, operating system boot devices. The first topic is operating system structure. As we know that operating system is an interface that acts between a computer user and a computer hardware. Each and every portion of a module here will be a well-defined one, and it having several input and output functions to be performed inside a system. These are the types of operating system structure: simple structure, monolithic structure, layered approach, microkernels, modules, hybrid system. Inside that, macOS, iOS, and Android. Moving to the operating system structure, it is very simple one. It does not have a well-defined structure. Microsoft DOS is the basic operating system. It provides different types of functionalities. It is divided into modules and structures and interfaces. It has no protection while providing the application to the programs. Moving to the second structure, that is Unix and the Linux operating system. It is provided the limited hardware functionality, and with no structure has been followed in this type of system. It is divided into two classification. One is a system program and another one is a kernel. Inside the system program, a signal get terminated and terminal will be handling by the different types of input output drives. Moving to the file system, the swapping will be performed inside a disk and tape drives. The CPU scheduling will also be done by the system calls while going to the kernel phase. The kernel here provides and act as an interface between the particular hardware, and it provides the CPU scheduling, memory management, and other functionalities to the system call. Moving to the next approach, that is layered approach, that is divided into number of layers. Layer 0, layer 1 up to n number of layers. Under a top-down approach, the overall functionality will be separated and it is moving to the layers. The bottommost layer is called as a hardware and the topmost layer is called as a user interface. It can invoke lower level layers from the top layer. The main advantage of this layered approach is the simplicity and the construction. We can easily identify the errors when it happens. Moving to the next technology, that is called as defining the layers into the structures. At each level, the parameter has been passing, and this parameter will be using the more different types of functionality. For example, we can say that the microkernels. Here in the microkernels, it provides minimal process and the memory management in addition to a communication facility. It provides inter-process communication, memory management, CPU scheduling, like that. The next process of this, it provides two types of messaging. One is message passing and another one is shared message passing. The main advantage of this message passing, communication will take place inside the kernel between a client and a server. These are all some of the benefits of microkernel. It is very easy to use. All the new servers added into the user phase does not require any type of modification. Operating system used here will run at the user level and produce the process and hand over to the kernel level. The rest of the operating system will remains unstable in this position. The next level operating system structure is a module. Here, the module which we take is Solaris, Linux, Mac OS, and Windows. On using this, at the initialization time, we will boot at every time of an environment. After that, it uses the several object-oriented approach. Each code component is separated and it linked by the interfaces. Each loaded program will then connected to the kernel. It avoids the problem of defining the updates. The updates will be easily maintained by this type of modules, which the help of the microkernel approach. We can say that the example for a Solaris operating system. Solaris is an operating system. It is organized around a core kernel with the 7 types of loadable kernel modules. For example, scheduling classes, file system, loadable system calls, executable format, stream modules, miscellaneous modules, device and bus drivers. The next system is a hybrid system. We know that hybrid system will combine the multiple number of approaches to address the number of tasks, performance, security, usability needs, and efficiency of a performance. They can be modeled into 3 layers, that is Apple, Mac OS, iOS, and Android. Moving to the first structure, that is Apple Mac OS, it uses a hybrid structure. The topmost layer is called as a Aqua, a user interface. It sets the application environment. So the second layer is called as Cocoa environment. It specifies the API program. The third layer is called as a kernel environment, which is using the BSD, that is used in input and development kit. The second architecture is iOS. iOS is a mobile operating system which is designed by the Apple to run on its smartphone. The topmost layer is a Cocoa Touch model. After that, the media services will provide the graphics, audio, and video services. Next to that, the core services will provide a variety of features, including the database services and cloud services. After that, the core OS will provide the bottom of the system which interacts with the user. Next to that, the Android operating system was developed by Android smartphone and tablet computers. In this variety of mobile platform application, all were open sourced. Linux provides the process, memory, and device drivers will support this hardware functionality to use into the code. Here we use a Dalvik virtual machine which will support and enable the Java language to run an API which then produce different types of software development kit and the SQLite programs here. Moving to the next topic, debugging. Debugging is the activity of finding and fixing the errors in the system, both in the hardware as well as in the software. If a failure or an error occurs inside the kernel, it is called as a crash. Whenever the crash occurs, the error information which is saved into a log file will move to that particular state, and the memory state is saved and it is went to the crash dump status. If this happens, the kernel will detect an unrecoverable error. From this, we cannot recover that particular condition. Here, whenever the system is going to be get reboot condition, a process has to run and gather the data from the crash condition. This can be done by performance tuning. Performance tuning is nothing but to improve the performance and removing the processing bottlenecks. Many of the operating system will produce the trace listing of the system behavior, whichever the work which we have done in the system. A Windows Task Manager, which is a similar tool for the Windows system to list out which are all the process which we have undergone earlier. Like that, they will list. After that, another mechanism of debugging is a detrace mechanism, is a facility which will dynamically add a problem to the running state. It will used in the Solaris tool, Mac OS, and FreeBSD. It will allow the production of the codes and it is executed with the provider, capturing the data. It will record the certain amount of data and it in a running code. After that, it will boot up the system. It will get loaded into the bootstrap program and the loader. Whenever it is loaded into the program and at a fixed location, it will first initiate it and store it in the ROM. ROM is it is used for the initial boot code. After that, the ROM is convenient, but no initialization cannot be easily infected by any different type of antivirus here. Some of the system of the cellulars may be used here for the entire operating system. For storing the operating system in the ROM, it is very suitable and it is because of the very small feature it supports several hardware environment. After that, we will having the EEPROM, that is electrically erasable programmable read-only memory, which can capable of read only the data, which cannot be able to write the data. All forms of ROMs are known as firmware because a problem with the firmware is generally executing the code is very, very slower compared to the RAM. Hence, this can be avoided. While loading into the program, the kernel will load the program into the memory and starts its execution. It is only that point that the system is set to be running. Thank you.